Hello and welcome to Interconnected, the podcast that explores the intricate links between life's most profound, weird and wonderful things. I'm Robin Taylor.
And I'm Jake Robinson.
And in each episode we discuss interesting topics that challenge ourselves to connect it with another subject that might be completely unrelated, sometimes trivial, and many times very quirky.
Sure, think anti-gravity and armadillos, or deep-sea mining and dark chocolate.
Dark chocolate? We hope you find the podcast thought-provoking and entertaining, and we invite you to explore the interconnectedness of life.
Cool, so without further ado, let's get on with the show.
All right, so let's interrupt the show and go back to our usual segment of actually what's our neck of the woods before we get back to the show.
Let's
Jake,
do it.
What's new in your neck of the woods?
Well, I've just been saying how I find Australian news quite boring. Well, I might cut that out. Anyway, so the first news story I found is that... Whoa.
Doors open.
Yeah. Jake gets deported from Australia.
That's right.
What? Oh yeah, I'm on a temporary visa. I mean, I love Australia and everything about it. Anyway, the first news story I find is after more than 15 years, the Chinese government is expected to announce that Australia's imported gentle giants, Fu Ni and Wang Wang, will soon be replaced by a new duo. Who am I referring to? Well, they refer to them as a pair of panda diplomats that were loaned to Adelaide Zoo in 2009, and they're expected to return to China soon. But it sounds like they're going to be replaced by some new so-called panda diplomats.
So I don't understand. Isn't there something quite recently, I think somewhere else, they've either the UK
Loaning
or the
pandas.
US? Yeah,
I don't know.
Like the idea about loaning, I mean, that was the interesting idea, being that diplomats, and they spend a bit of time and then they go back home and I don't know what they do. What do they? They go on book tours or?
Yeah, it doesn't sound very ethical, does it?
Yeah.
Just calling them panda diplomats to begin with is a bit off. But anyway, what's new in your world in Fiji?
So the only thing that's a bit new is probably not as warm and fuzzy, but basically we had our politicians, many of which decided that it was a good idea, despite inflation and the cost of living rising, to award themselves a over 100% pay increase.
Wow.
And the opposition also decided that was a good idea. And that's brought about a big brouhaha. Interestingly, the existing government is a coalition government, and one of those parties actually of that coalition refused to. So that's one of the few times where the politicians actually were being quite ethical and grounded and said, no, don't want to do that. So
any jailed politicians this week or not?
Not that I'm aware of, but the coconut wireless is going strong.
Fair enough.
Rumors, but we
Do you know what's happening in New Caledonia?
No,
a few weeks ago it was pretty raucous, wasn't
it?
Yeah, okay. All right, let's move on. So,
what are we talking about today?
Alrighty, so today's main science topic is solar power or solar energy. What is solar power in a nutshell, Robin?
All right, in a nutshell, I'm going to kind of not try and get ourselves into hot water by saying that effectively all power is solar. Could be deferred. But we're talking typically about, in everyday language, we're talking about the ability for us to generate electricity or energy via solar radiation. And typically that comes in a form of different flavors. The current ones that people are looking at, the oldest one is using solar panels to heat water. Then you'd have basically what are called photovoltaics, and they are using chemical processes that is not totally unlike photosynthesis, but effectively it's causing a electrical potential which can generate a voltage. Mm-hmm. And there's another one which is called concentrated solar power, and that's basically where you have mirrors and it reflects onto a focus point, and then you heat something up, and then you use other mediums such as water to go through. So the thing they heat up is, I find really fascinating, is molten salt. So it melts salt, and then you put water tubes through that to drive turbines and things like that. So that's basically what solar power is.
Yeah, so we're mostly focusing on the technological side of things. We're drawing from that beacon in the sky, but we're focusing on the technology.
Correct. And I think that one of the things that the nutshell should have actually provided is, of course, it is a renewable source of energy.
Yeah.
And therefore, the big interest in solar power is because it does not contribute towards carbon dioxide emissions that we get from fossil fuels, and so therefore should not drive climate change. So that's why there's such a big interest in it. Yeah. Unfortunately, solar power suffers because there's things called clouds and cloud cover, And so you can't guarantee that the
Yeah.
sun is always on, and therefore the solar power isn't always working to our satisfaction. So that is where we're sort of at. What do you think of solar power? Do you think it's something we should be excited about, or?
I think it should contribute to, I always like to take a multi-pronged approach to these kind of big issues. And I think solar power definitely can contribute alongside other renewable forms of energy. Just one point, you mentioned concentrated solar power and these mirrors. I have an interesting story about that. We've had a podcast episode before on vultures and rabies.
Oh, yes.
Yes, so I'm writing a chapter on that in a book about infectious diseases. And I've come across a story related to a group of people called the Parsi community. And they're this small group of people, I think they're from Iran originally, but they migrated to India. And part of their religion, they have a different form of a funeral compared to a lot of people. So once their family and friends die, they put them on top of a tall tower and basically leave them outside for vultures to come and pick them off and decompose the bodies. So that's like one of their kind of lifestyle rule in their society. They must die by being decomposed by vultures and other scavengers. However, because of this whole diclofenac issue, wiping out the vultures. This is that anti-inflammatory that's essentially poisoned the vultures and caused this massive vulture population decline. Therefore, they're leaving bodies on top of buildings and there's nothing there to decompose them, nothing there to remove them.
Oh.
So it take a couple of vultures, sort of like an hour or so, to rip a body apart and decompose it. However, without the vultures, it can take days and weeks, etc., to decompose naturally, which obviously increases the disease risk in the area. So what they've actually turned to is a definite no-no to bury them, because one sort of rule that your bodies can't touch soil and fire or something. It's a strange but interesting, religious kind of quirk. But essentially what they've done is they've turned to technology. Because I assume the Indian government's like, well, yes, the vultures are dead, but we can't have rotting bodies everywhere and disease is being spread. And they're actually using this concentrated solar power thing. So they're basically setting up a load of mirrors on top of the towers to concentrate the sunlight into the bodies. And then that speeds up the decomposition rate of the bodies.
So they're basically warming it up so that so the bacteria can actually get to work faster.
Exactly, yeah.
Oh, wow. Okay.
So that's one form of that concentrated solar power.
That is. But that would be a very gentle one, wouldn't it? Because the ones that we're talking about, we're getting to thousands of degrees Celsius and stuff like that. One of the things that I haven't understood very well about solar power is that whilst it looks like it's a panacea and you kind of go, well, so you were saying before, it contributes towards, what we're doing. And I think that's probably right.
Yeah.
I do think that we are still being a bit silly about the way that we're thinking about our power or energy generation, and therefore we're probably not thinking about solar power in the right way. So it's interesting you say, it has to be a solution. I'd love to hear more about what you think about that. But what I worry about is the fact that, have you read things about it's the end of life cycle of photovoltaics? And although we're getting bigger and better, panels, but apparently the material that is being used is quite poisonous to the earth. And if people we know that we're not really responsible on a large consumer scale for things like that.
I think that is definitely one of the concerns, is the materiality of the panels, for sure. So that you have to smash up the earth to grab the rare earth elements, don't you, that go into the panels?
Yes, that's the manufacture.
Okay, are you thinking about what happens to the materials then? Are they recycled properly? Do they degrade?
Yeah, and we know they're not. They're just, that's why they're talking about these things just leach into the ground and, then causes environmental destruction from that point of view. And again, it seems like, we're not thinking a lot about that. And, some of the things that I do think is a bit weird about, let's say, the solar panel technologies that are being used is when you, let's say, use a photovoltaic to generate electricity, and then you put the kettle on. So in other words, the older technology of using solar panels to heat water, even if you're just heating it by a couple of degrees, because of the kind of the thermal properties of water, that actually would be a huge impact on not doing that. So I feel like we need to be looking a lot more at solar panels that allow us to work in conjunction with other things, such as having photovoltaics and water heating, or heater. Stuff that's there almost in conjunction, so that, if you have, let's say, a household appliance, then you are generating electricity, which would only be used for things other than heating water. Interestingly, about photovoltaics, remember we spoke about biomimicry.
Yes.
And then, that's, I think, where the exciting stuff is that trying to figure out how to get our photovoltaics. So I think the best photovoltaics are around about 30% that we're getting transferring from there. And that photosynthesis is 90+% of turning sunlight energy into energy that is being used by the organism. So yeah, we've still got a long way to go in terms of trying to figure out how to convert something into an energy source in an efficient way. So there's definitely room for improvement.
There's probably, I assume there's room for improvement in the battery storage side of things as well.
Yeah, you're right. Let's go back to that idea about the concentrated solar power with the mirrors and the fact that they're using effectively a heat battery, but it is molten salt. It's just you can think about, so they have molten salt at the top of a tower that you're doing there, but you could also use the thing to basically have underground insulated chambers of molten salt, and it effectively becomes a battery. So instead of I always thought of batteries as being chemical, but it could also be a heat thing where you're holding this molten salt at a really, really high temperature, and then you can just turn on the tap to feed your water through to heat it up really quickly, and then turns into steam and does turbines and stuff like that. Yeah. So yes, I think that there's a lot of room for batteries other than chemical, electrical.
So these are kind of components that store excess solar energy for when sunlight's not available?
Right, absolutely. Yeah. What do you think about the idea about solar power generation coming from large solar power plants versus having it distributed across households?
You often hear people saying, well, the Sahara Desert, it's a vast expanse of millions of hectares. Why aren't we just plastering the entire surface with solar panels? What's your view on that?
Well, that one there is actually, there's been some studies that have shown that it would be a disaster for us.
Yeah.
And the reason is because although theoretically you could do that, but there's been some calculations done that the change in albedo, the reflectivity that would be required, would effectively mean that the local environment would heat up significantly. And then that would actually affect globally. So we would get something like a 1.5 degree. That's okay because we could turn an air conditioner.
Yeah, exactly. It's interesting you should say that, because there's a similar issue in the whole kind of tree planting narrative. So lots of people are saying, there's enough room on the earth to plant 300 billion trees or whatever it is. But many of these spaces are places that are lightly coloured grasses or arid areas anyway. So if you end up planting trees, they're not supposed to grow there anyway. So it could probably destroy the ecosystem. But B, it does affect the albedo effect, because you're obviously planting things that are darker than the original surface. So you could end up planting trees only to increase climate change, which is the reason you were planting trees in the first place.
Exactly. Yeah. I do think that to come back to the question, what's my take on it? I do think that there's something to be said for that we should all be responsible for all producing a little bit of everything, and that you would have a central supply, which would basically give you a baseline or something like that. So I am really interested in the idea about what's called microgrids. So you would have basically myself and my neighbors around here, we all have our own solar panels, but we'd also be connected. I think there's been some pioneering stuff done in India where you've got small boxes. So it's kind of measuring who's loaning, who's giving or donating their solar power energy to someone else into the battery. And then there's some sort of way of doing it. And then, of course, what can happen is you can get microgrids that then connect to other microgrid areas. And so therefore it starts to look a lot like the internet, especially the way it was originally designed, which makes it very resilient, because you've got this idea that the internet was originally a response to the idea that central commands, once they're taken out in an escalation of war, meant that that's game over, as opposed to having your central command now distributed across all sorts of nodes. So one node means that the other nodes just take up the slack. Horrible to say that we can save the world by thinking about war games. But, but there is some logic there.
Yeah, true.
One more thing which I thought I'd just fire past you.
Yeah.
Have you ever looked at it's this idea of, there's a scale, there's a civilization scale that, it sounds like a Russian person. I can't remember exactly what it is. I could look it up shortly, but talked about civilizations in terms of their energy usage and their energy needs. And so we are the ones that would be generated. So we're in civilization stage 1, where we're using the energy that we can generate on the earth. So and it fulfills our needs. So we haven't, I guess we are doing it, not successfully, but we are doing it. And then civilization 2 is where you start capturing all the energy that you need from the sun. And usually you do that by putting effectively loads of energy capturing units around the sun. And it's called a Dyson sphere. People think it's like the whole sun is enclosed in a sphere, but it's more like a grid or a network. And that supplies all the needs for the citizens on whatever your system is. And there's been a lot of interest quite recently in the astronomy worlds, because if that was to happen, there would be a unique signature that would come off from that, where there'd be a lot of infrared, more infrared than you would expect from around the sun. If you made this Dyson sphere. So Dyson is obviously named after a guy who thought about this, but he actually referred to it from a book that was written in the 1930s. But there's been some recent speculation in the last couple of months. They're actually finding signatures in the world, which is suggestive of potentially it could be a Dyson sphere, which would mean we're looking at civilizations that are highly advanced, and it's in our Milky Way. I think they're looking at around about 50 of these, 7 of which are highly interesting. Of course, they're not saying it is a sign of civilization outside of our world, but they are saying it could be. So our discussion about solar powers brought us to discovering extraterrestrial intelligence. How about that for a link?
Wow, that is good. Was that your actual link?
No, that's not a link.
That's to come. That is cool. Very interesting. I've got a couple of fun facts that I thought we could finish off the discussion on solar power. Okay, so the concept of harnessing solar energy through photovoltaic effects dates back to 1839. So French physicist Alexandre Edmond Becquerel discovered the photovoltaic effect, which is the operating principle behind solar cells. So yeah, it's got quite a rich history dating back to the early kind of industrial revolution times. So we mentioned the ISS, so solar power panels are used to power satellites and the International Space Station. An average home solar power system can save around 100 tons of CO2 over its 30-year lifespan. The solar industry is a major job creator, so we haven't spoken about the social side of things. So in the United States, the solar workforce grew by 167% over the past decade, reaching 250,000 workers in 2020. Okay, so let's move on to the main part of the show, Interconnected. So in each episode, we cover a main science topic, but we also challenge ourselves to link it with a topic that may seem random or unrelated. This week, it's your turn, Robin. So what is the topic and how is it connected to solar power?
Right. So I'm suggesting that, or my topic is, in the quest to become climate friendly and introduce solar power stations, our ability to enjoy a tequila is significantly affected. So
please
here
explain.
We go.
Yes.
All right. So the main plant, the cactus that makes up tequila, is agave. And it lives in arid and semi-arid areas. And you mentioned the idea about, solar panels being something that could be deployed in a desert like the Sahara Desert. So imagine if we do actually do that. And what people don't realize is that the desert ecosystem is in fact a viable ecosystem. And I would have been surprised to learn about something which would be in your arena, Jake, which is soil crusts. And that basically by putting in solar panels, you're effectively potentially ruining a soil crust. What is a soil crust? Well, it's a microbiome which consists of lots of things, including the bacteria and fungi that kind of holds things together. And it's a little bit like it enables the rest of the ecological system to be able to function in a desert, which means things such as water and nutrients going through the actual ecosystem that's there. And of course, that brings us to the agave plant itself, which needs all those things there. So if we disrupt the soil crusts of deserts because we put in our solar panels to try and do energy production, then we're going to find that we're going to be destroying the crops that eventually become tequila.
Wow, that's good. I like it. I like your big picture thinking and then your small kind of tequila picture thinking. That is really cool. I will give you 8.8, I think.
8.8.
That's good. Yeah.
Oh, well,
maybe 8.9 because tequila is one of my favorite drinks as well.
Oh.
I just thought of a couple of things that you could add to that, though. There's a particular species of large bats in South America and Mexico, etc. The agave plant relies on for its pollination. So without the bats, the agave plant wouldn't exist either. But that might occur the other way around as well. So without the agave plant, the bat populations might significantly decrease because they haven't got their pollen and nectar feed. So potentially it could also alter bat populations as well. Good link.
Can you tell us a little bit more? Because I'd never heard about the soil crusts.
Biocrusts, yeah. So soil crusts are also called biological soil crusts, or biocrusts for short. It can be a mixture of things, but they're often these kind of conglomerates of mosses, lichens, algae, cyanobacteria, and then obviously they have the microbiome, as you mentioned as well. Essentially, they're like this maybe 1 to 5 centimeter layer of, it's almost like a nice biological carpet that covers deserty areas and arid areas, like you mentioned. And it does bring in important resources like sugars and nutrients, etc. Provides nutrients for invertebrates. So it's kind of a keystone conglomerate that supports the ecosystem.
I mean, the way I was reading it was that it also, because it says crust.
Yes, they are crusty.
It's got this ability to, as it were, be a protective layer for things that are living underneath.
As well.
Right.
So it provides a layer for moisture retention as well. Yeah.
So basically, all those people that go tearing around on sand buggies and kind of think that they're not doing anything to the environment because it's just sand, don't realize that they might be.
So you probably get a very thin layer on things like dunes, just because they're so dynamic and they're constantly moving. Deposition, erosion, etc. But the more stable environments and these arid areas, you'll often see them as kind of just slightly green discoloration on top of the sandy substrate. And it's often a very rich and diverse ecosystem in itself. So biocrusts. Really cool. So I could see, plastering these kind of arid areas with these huge photovoltaic panels, blocks out the sunlight, creates an entirely different niche under the panels. So I can see them affecting the soil crust significantly. It might end up selecting for different organisms, ones that don't require sunlight as much. So you might.
That's right. But it also, just to manufacture it means you're kind of crunching your way over the crust. And so therefore, it'll take a while. I don't know how long the crust takes to form. But
so lichens are really slow-growing organisms, and they're comprised of different organisms that have to meet as well in order to form that conglomerate. It can take decades to even for lichens to kind of grow and proliferate over
so on a human
smallish
scale,
areas.
Disaster.
Exactly.
Biological scale, who cares? But in the human scale, really, really massive.
It's a great link, though, because you can see the cascading effects throughout the ecosystem. So we've mentioned soil crusts provide moisture and nutrients, which then probably helps the agave plant survive. But also it's really important in the general food chain of that ecosystem. So it helps invertebrates, and then invertebrates feed birds feed, etc. So you can see these cascading impacts of simply just planting some panels over the top of a perceived desolate area. Yeah, good one. Yeah. There's also the backlink as well, which is cool.
And the backlink,
Nice.
All right.
Cool.
Okay. So, Jake, what are we hearing down on the quantum level from the invisible world?
All right. So I thought I'd briefly talk about fungi today, and not from a beneficial perspective. So I wrote an article the other day about how fungi contribute to nearly 4 million deaths annually of people. This is mostly because my headspace in the minutes in writing an infectious disease book. So normally I would promote microbes and how amazing they are at sustaining our lives and our ecosystems, which they are. But my headspace is in that kind of infectious disease area at the minute. So I've chosen fungi and pathogenic ones. So fungi contribute to nearly 4 million deaths annually. And this is more than the likes of malaria, TB, AIDS, and cholera. So they're often preventable deaths, and they receive far less attention and funding. So it's something like only 1% of all infectious disease research funding goes to fungi. So why is this? So I've kind of deduced several reasons why this might be. Fungi are eukaryotic organisms. So like humans, it makes it challenging to develop treatments that target fungus without harming human cells. This complexity can deter research and development efforts. So that's one reason. It's that fungi are very different to other infectious pathogens like bacteria, which are prokaryotic. So their DNA is much more like humans, so it's actually harder to develop treatments without damaging human cells. So fungal infections are often perceived as less threatening compared to bacterial and viral infections. This perception is partly because many fungal infections affect people with weakened immune systems, making them seem less relevant to the general population. Historically, medical research has prioritized bacterial and viral diseases, which have been more prominently featured in pandemics and outbreaks. You can think of plague or Ebola or COVID recently. As a result, funding agencies and researchers focus more on these areas. There's also less public awareness and recognition of fungal diseases, so many people are unfamiliar with the symptoms and impacts of fungal infections, leading to a lower perceived need for research and funding. They're also quite difficult to diagnose as well due to non-specific symptoms and the need for specialized lab equipment. And pharmaceutical companies may have fewer incentives to invest in antifungal drug development compared to antibiotics and antivirals. The market for antifungal treatments is somehow smaller, and the financial returns are perceived to be lower. There's a nice quote here from Justin Beardsley. He's a doctor. He says, "Fungi are the forgotten infectious disease. They cause devastating illnesses, but have been neglected so long that we barely understand the size of the problem."
Let's go back to what you were saying before. So the beginning part was you were saying it causes more deaths than go to that statistic again.
Yeah, this has blew my mind as well. So it causes more deaths annually than the likes of malaria, TB, AIDS, and cholera. Malaria was particularly the most surprising one for me. Malaria causes something like 2.3 million deaths annually.
So I guess what I'm trying to say is I can't quite square that circle where you were saying, Big Pharma doesn't want to look at this as being an area to go in, but yet if it's bigger than, what are their markets
it's very
for?
confusing. Yeah, it's confusing. Yeah. So that's why I haven't worked out the reason for that yet, for the pharma thing. It's so pharmaceutical companies may have fewer incentives to invest in antifungal drug and development compared to antibiotics and antivirals. Maybe it's a perceived incentive.
Maybe
the market for the treatment is somehow smaller. Yeah, it blows my mind. Why?
I was going to say maybe Big Pharma's a lot more human than we paint them to be, the horrible capitalists that they are, because they somehow think that fungi are cuter than bacteria.
It's an interesting perspective, maybe.
Yeah.
But yeah, they do often affect people with already weakened immune systems. So that's an interesting point, how, it might be immunocompromised, older people. So the general public doesn't affect the general public as much, which is not very nice.
That's a big topic to talk about.
Interesting. And the whole eukaryotic organism thing that I mentioned is one of the main problems, I think, because the DNA of fungi is more similar to ours. So actually developing drugs is quite difficult.
But help me out here. So my sort of memory of fungi is that, yes, it may be eukaryotic, which, just give us a definition for that so we know what the difference between prokaryotic and eukaryotic is.
Yeah, so it's an organism with a membrane-bound nucleus and organelles as well. So, like some algae, plants, and animals are eukaryotic compared to bacteria, which are prokaryotic. They don't have a membrane-bound nucleus. They kind of have free-floating DNA and generally considered to be less complex. And they are unicellular, so they're generally only one cell.
Right. So what I do find really weird, but just to remind me about the fungi, I seem to remember the anatomy is, although it does have membrane-bound nuclei, they don't seem to have cell walls, do they? There seems to be almost baffles. And also they don't have cellulose, but they have chitin, don't they, as their outside structure?
Yeah, that's right. It's the primary structure. So it's a kind of long chain of polymers.
And this is the thing where
it's similar to cellulose found in plant cells, but I think it provides more kind of rigidity.
Yes, but it's a different kingdom. So we might need to go through a little bit of classification here just to understand. But yeah, the main kingdoms are plant, animal, fungi, bacteria.
Yeah. So there's different kinds of classifications. You can talk about domains of life as well.
Right. Yeah. So I guess what I'm trying to say is that given it is a different kingdom, I just find it interesting that you're saying that the similarities are enough that it would cause problems, that any antifungal properties would actually probably affect us as well. Because I always assumed that
apparently
they were so different from us that,
no, apparently it causes complications just because of the similarities in the DNA.
So I only know of two fungal diseases that I know of, which is basically athlete's foot, tinnitus, and ringworm. Which ironically is not a worm.
Yes. Yeah, that's interesting. Yeah, so the main pathogens that are killing everybody is Aspergillus fungi and forms of Candida.
Okay.
So some people may know this, Candida albicans. And it can generally cause relatively mild symptoms in many people. It's the people that are immunocompromised that it then causes more complications. And you find fungi in grains as well, so improperly stored grains. This is probably one of the reasons I think many of these deaths are preventable. It's thinking of this from the systems perspective, it's going back to where these fungi are found, and often they're found in living in grains that are not stored properly. So people are consuming the grains that are infected by these pathogens. So you can see how many of these deaths could be prevented by helping people to.
Are there any symbiotic organisms that you know of that are, they have fungi as sort of fungi and something else? Like, in other words, how we spoke about lichens?
Yes.
So that's basically algae and what is it?
Algae, yeah. So there's the mycobiont, which is the fungi. So myco basically means fungi.
So lichens is the only one.
I mean, there'll be symbiotic relationships between fungi and many organisms, but lichens is kind of this bit of a unique case where the classification of a lichen is defined by this relationship, whereas you might get fleeting fungi that in and out of our bodies that provide symbiotic benefits, and we provide benefits to them, but we're not defined by that association.
Right.
So there are probably loads of beneficial fungi as well, but it's quite a nascent field actually, because we've been so focused on bacteria and viruses that we definitely need to understand more. But from a pathogenic perspective, it's fallen under the radar, hasn't it? 4 million deaths a year. That is insane. So
that is wild.
It is. And there's this program on recently called The Last of Us. I think it's on HBO or Netflix or something.
Oh,
it's basically about cordyceps infecting the brain and turning people into zombies.
Honestly, this obsession
it's kind of related
to
climate change in a way, because it's saying like got a heated climate, and then the fungi has evolved to resist or tolerate the heat of our bodies. So that's one of the main reasons we're not infected by fungal pathogens all the time, is because fungi don't really like the heat.
Right.
But then there's this idea that they could one day evolve to be heat resistant and then causes all sorts of issues. And these kind of zombified examples do occur in nature. You've probably seen like ants with their brains exploded with fungi that have infected them. And then the fungi take over their brains and make the ants do all sorts of weird things. So there are examples in nature, but it's probably unlikely to happen in humans. Fingers crossed. Zombie ants.
Lordy.
Yeah, check them out.
Yeah.
Cool.
Okay.
Should we wrap up?
Yeah.
Anything else you want to mention before we finish?
I'm going to be looking at the news of these Dyson spheres and see if we need to build bunkers and or make big signs saying peace be upon you.
Yes. Sounds like a plan. Do you watch many series? There's one called, is it the 3-Body Problem or something?
Oh, I would like to look at that. I haven't seen it, but
sounds relevant to what you were talking about. So check it out.
Okay.
All right, let's wrap up. We're excited again to present the next episode of Interconnected to you in a couple of weeks. And thanks again, everybody, for tuning in. We'll see you next time.